Hey everyone, welcome back to the world of generative AI. Today we are diving into concepts that truly make AI feel smarter, semantic search. If you ever wondered how modern search engines or chatbot seems to get you, even when you don't use the exact words, you are about to find out why. Let's start with basics. Traditional search engines rely on keyword matching. If you search for best book on AI, they look for pages with exact same words. But that's pretty limited. Semantic search, on the other hand, focus on the meaning behind your query, not just word. It break it down visually. It understand context, intent, relationship between words. Instead of matching string, it use embeddings, a neural vector that capture meaning, which we discussed earlier. So, if you search for how to train a neural network, it could return result for deep learning tutorials because it understands the connection. In short, semantic search is what make AI-driven systems smarter, more human-like, and a lot more useful. There might be a question in your mind, where is semantic search used today? So there are many real-world use cases. Some of them are AI chatbots, voice assistant, search engine like Google, recommendation system like Netflix or Spotify. In all of these, it's not just about what you said, it's about what you meant. With the help of semantic search, the AI can understand what you really want. Let's walk through how semantic search actually works behind the scene. Here the process in 4 steps. First step is convert text into vectors. First, your query like healthy breakfast ideas is passed through an embedding model like OpenAI, BART or sentence transformer as we discussed earlier. The model transforms it into a vector, high-dimensional representation that captures its meaning. The next step is store in a vector database. That also we discussed in earlier video, why we need vector database. After creating vectors, all our vectors of like documents, articles, product description are converted into embeddings and stored in a vector database, which we discussed in the last video. The third step is query. When user make a query, that text also converted into vectors so that we can search for similar vectors in VectorDB. The fourth step is similarity search. The system runs a similarity search between the query vector and the stored vector. It uses metrics like cosine similarity to find the vectors which are most similar in meaning, and those become your search result. Notice that at no point does the system care about exact keyword. It's all about closeness in vector space. That's what make it semantic. You can understand it in this way. Like you can thought a 3D space filled with dots. Each dot is a document embedding. Your query create a new dot and the system find the nearest neighbors. Those are the most relevant answer. And those will be your search results. To sum it up, semantic search let machine understand what you mean, not just what you say. Power of embeddings, vector database and AI model, it's at the core of modern application, from chatbots to personalized search. In next video, we are going to show you how we create embeddings, how we store those embeddings in vector database, and how we do semantic search through code.